All right, all of this is fine and dandy and sounds doable until we remember that not all time is recorded in the geologic record, and we call these gaps in time unconformities. So what I mean by this is I think of the geologic record, right, the layers of rock beneath the Earth's surface as a history book, where each layer is preserving information, preserving evidence about the environment when that layer was created. However, sometimes you'll get an unconformity in the rock record. And this might be, maybe an entire page was ripped out of that book, or maybe, the part of the book was burned or something like that. Something that would remove that information from the geologic record, remove that information from the history book. So unconformities, there are gaps in the geologic record that record or represent times where no deposition occurred, or if deposition did occur, the material was then eroded away and removed from the book. Okay, so there are three types of unconformities. The first is an angular unconformity. An angular unconformity occurs when at that unconformity, right, at that boundary in the rock record, below the boundary, the rocks are at an angle, they're tilted, they're folded, something like that. And then on the other side of that unconformity, the other side of that boundary, the rocks are flat or at maybe a different angle. So this tells us that, right, something had to have happened. There has to be some time missing in the rock record, right? First, material was deposited and that material was folded and tilted. Then that material was eroded away so that new flat layers could be deposited on top. That's an angular unconformity. Next up, we have a nonconformity. A nonconformity is when we have sedimentary rocks lying on top of older rocks that are not sedimentary rocks, right? So they're either igneous or metamorphic. And we know that an unconformity has to exist here because while sedimentary rocks are deposited flat, igneous and metamorphic rocks are not deposited flat, right? They are formed in all sorts of weird shapes. And so if we see a flat unconformity between these two rock types, we know that the underlying igneous or metamorphic rock had to have been eroded flat before the flat sedimentary rocks were deposited on top. Finally, we have a disconformity, and these are often the hardest to see in the rock record. You have to really know what you're looking for. So disconformities, this is when there's a gap in time between two sedimentary layers, right? A gap in time where there was some erosion or maybe just no material was deposited for that amount of time. And then we get a disconformity, right? So that's sedimentary on sedimentary. All right, so test yourself, see if you can name these unconformities. The first, we have a sedimentary layer on top of another sedimentary layer, but we know there is erosion in between those two. The next one, we have sedimentary layers, flat sedimentary layers on top of angled sedimentary layers. And then the third one, we have sedimentary layers on top of an igneous rock. Okay, so hopefully you were able to see the first, sedimentary on sedimentary, that's disconformity. Flat layers on angled layers, that's an angular unconformity. And sedimentary on top of igneous, that's a nonconformity. And all of these just represent gaps in time that have not been recorded in the rock record.